Hey everybody, well in this video what I'm going to do is I'm going to do this problem, two problems actually, involving logarithm and illustrating the properties, some of the properties of logarithms. So I'm going to write down first of all some properties that we have. So I'm not going to show all the details. I'm not going to write down quite everything. If I have log x times y, I have log x plus log y. Now, what I didn't show is the base here. Actually, if you have log with no base, it's considered to be base 10. But what I mean here is that regardless of the base, as long as the base is, fits a certain criteria, but regardless of the base, you have this property is log xy becomes log x plus log y. So inside the logarithm function, when there's product, if you break it up into two different logs, now we have multiplication. Now, there's another one where I have division inside, or quotient, or something, a fraction of x and y. If I break that up, so do you see log and I have xy? If I break that up, then what I get is subtraction. And the third one that I'm going to write down is log x to the some power. I'm just arbitrarily going to pick some number, letter, variable, or some constant r. If I have log x to the r, that equals r log base x. Now these properties are really good ones. They're really important, and often that's why logarithms are even used, is because they have this property. So sometimes you see a problem, no logarithms, and then you bring the logarithms in. Now, what we're supposed to do is expand this expression that we see here. Now, the problem is I just did those properties things and took up some space. So let me see if I can just scoot those down here a little without making a huge mess. Okay, how about that? So, okay, what I'm going to do is I'm going to use these properties a multiple amount of times. See, I have, what you can see is there's w, x, y, and z. Okay, what I'm going to do is I am going to use these properties a multiple amount of times, and I'm going to create a little log for each of those variables and their power. In the meantime, while I'm doing this, I'm going to take this z, square root of z, and I'm going to write as z to the 1/2. Okay, so there's just a little fact, is that square root of z is equal to z to the 1/2. I mean, that's another, I don't know, thing to talk about, but that's true. Okay, now, because of the product, number one, we have the product xy equals log x plus log y. Well, in the numerator, I have a product, and I'm going to put a plus here. Now, I have x divided by y. That's w cubed x to the 5th. I'm dividing. That's why I get a minus. Now, you could look at it this way. I'm going to write this for a minute. I have y squared times the square root of z. That gives a plus because it's a product. I usually shorten this, and I don't think about this intermediate step. All I think is, if it's in the bottom, in the denominator, it gets a minus in front, because we're going to see that negative distributes. I'll do that the next step, I guess. But now let's go on to dealing with these powers here, exponents. Let's bring those to the front. So see, the thing is a lot of people, I think, get really good at this. I forgot to do base 2 here. Okay. A lot of people get really good at this, just a little bit of practice, and they do this all in one step. Now, here I'm bringing I bring that power of 2 to the front, bring all those powers to the front. I'm going to do that. Now, I'm also on this, when I have the minus, I'm going to distribute that at the same time. So I sort of combine some steps there. The thing is, the way I look at it is, if it's in the numerator, when I'm doing these problems, it gets a plus in front. If I want to write like plus 3, looks funny doing that. I'll probably erase it. But plus 3 log base 2w. Okay. Then I have plus 5. Everything in the numerator gets a plus. Everything in the denominator gets a minus. So you could do this step, but I've gone over this in a lecture. Okay, so this is not the first time I've gone over this. But, so you can show more work of why this happens this way. But actually, maybe I should have done that from the beginning, but show more work. But still, the numerator breaks up w to the third, x to the fifth. That breaks up in log base 2 above sum. Then I use property 2, where I have this fraction and I have this difference, so it's minus, but the denominator has a product, so I break that in the sum, and then the negative distributes through. So, well, on this problem, the answer is what I have down here. Alrighty, now let's do this. That's a good one, but let's see if we can now reverse this and combine everything. Let me move this up just a bit, and so I have more space and I can keep everything on one screen. Okay, so let's combine everything. So I'm going to work backwards here. A lot of people just can do this, get good at this, and they do this all at once. I'm taking these coefficients here that are sitting in front, the 2, the 4, the negative 3, and the 7. Actually, I'll just, okay, let me show you what I'm going to write. I'm going to have ln x squared plus ln y to the fourth. I'm not going to care. I'm going to leave the minus down there. I was sort of implying that I'd bring the negative up, but I'm going to leave the minus, and I'm just going to, so it's a little bit low on the page, so I'm writing a little funny here. Let me move it up. Okay, then I'm using this idea that, I can break this up into steps, but if I have a product, I don't think I'm going to break into steps. I'm just going to use this idea I'm trying to convince you of, that if it has a plus, it goes in the numerator. If it has a minus in front, it goes in the denominator. But a longer way, if I were so inclined to do this, is that this is equal to ln x squared plus ln y to the fourth minus parentheses ln z to the third plus ln w to the 7. If I felt like I wanted to convince myself why I could do that little short step. And now I took out the minus, I factored out a minus. And then I'm going to use the property of multiplication, where I bring those together, the first property from my list above. And I'll do the same over here. And then since I have a difference, I'll finally bring them all together. But this is sort of getting cramped there. But I don't have it written down as a rule. But I have it in practice. I'm doing this idea that, as I said, is that let me just finish this. I need more space when I write down this. If that logarithm, as we see here, relating to what we have here, okay, if it has a minus in front, it gets up in the bottom. If it has a plus in front, it ends up in the top. Okay, that's what's going on there. Right? If it's a minus, it ends up in the bottom. The plus, it ends up in the top. And all this stuff here was just an idea. Well, I could show some work, but I don't think it's necessary, because I think it's pretty quick to see what's going on, how this works. So this right here is the answer. I don't think I want to necessarily show all those little steps, because maybe one time around, but I don't think we need to do that when I'm working out the problem. That's my answer. Alrighty, so zoom out and get both of those right there. So, I want to just impress on you. I think you can do this quite quickly. Actually, I think you just go straight to the answer. If you practice these a little bit, the 2 comes to the front of the x is x squared, y to the 4th, z to the 3rd, w to the 7th, and whatever has a plus gets in the numerator, minus gets in the denominator. And then you can the other one's working the other direction, and you can use the same ideas that if the power becomes a coefficient in front of the logarithm. If it's on the top, it gets a plus, and if the logarithm does, and if it's in the denominator, it gets a minus. So I don't think you actually have to even show that much work. I just did maybe to confuse everything, but anyway. Okay, that's all. Thank you.